Okay, so this is a hypothesis test, and now we've got a dependent sample. It's actually a before and after study, which is a common example and application of dependent sampling. When you're going to do a dependent sample, you're going to use a t-test, and this problem has to do with deer populations before a highway and then after the highway was built. So the first thing that you've got to do is calculate the differences of the before and afters. So I've just went through here and I've subtracted 10.3 minus 9.1 equals 1.2, and I've went through and I've done that for every single district, and there are 10 districts. Now if you have a graphing calculator, all you really need to do is enter this data into one of your lists, probably list 1, and then you can use data when you calculate your p-value with your t-test. If you don't have a grapher, don't worry about it. Find the average of the differences and the standard deviation of the differences, which I've already done. And if you're wondering how to do that, then I suggest you go back and you review your notes or lecture videos from what we covered in Unit 1. Now, we're going to do a hypothesis test using a 5% level of significance, and we're testing the null hypothesis that they're claiming, which is there is no difference between the before and the after in regards to deer population. And we're trying to test the claim that due to this highway, maybe the deer population has reduced. So there is a significant reduction in deer population. The symbol for that, for a reduction, is less than. Okay, the deer population has reduced. Okay? In the critical value method, in the traditional method, you're going to find a critical value with it's going to be a t, because it's a dependent sample, a t with alpha 0.05, degrees of freedom n minus 1, and there are 10 districts, and so we're going to have 9 degrees of freedom. And if you wanted to look up your critical value on a t table, it's a one-tail area. Alpha is 0.05, so you go over to the 0.05 on the one-tail area row, then you go down to your 9 degrees of freedom, and I'm finding a t of, I'm on the wrong row, 1.833, but it is a left-tailed test, so it's a negative 1.833. Shade the left tail. Again, because this inequality symbol is pointing left, so it's a left-tailed test. It's a really simplistic way to explain that. There's a more theoretically intelligent sounding way, but I'm trying to teach you a simple method. So pointing left, shade left, negatives are on the left. If you're doing the p-value method, you would have entered the data into your calculator or the statistics. You would have brought up a t-test, and you would be getting a p-value of 0.9958. And then, of course, you compare it to alpha. Now, this is just for the graphing calculator, guys. The rest of us, we're old school. We're going to do a test statistic. So we're going to take the difference, the average of the differences, or the difference mean, d bar, which is 4.45, which I had to calculate manually from the differences. We're subtracting off the differences that they're claiming, which will always be 0 in this scenario, right? It's always there is no difference versus there's some sort of difference. All divided by the standard deviation, which is 4.16313, which I calculated manually, divided by the square root of n, which is dividing by the square root of 10. It equals 3.38018, and then you look to see where that test statistic falls in your picture. Does it fall in the rejection region? Well, it definitely does not. It falls somewhere way over there. And if you look at the p-value, p-value is 0.9958. That's really high. It's definitely greater than alpha. So in both methods, we are going to fail to reject H0. And based on this evidence, there is no, or there is not a significant drop in deer population after the highway was built at an alpha of 0.05. Okay? So there doesn't seem to be a significant drop. Again, you have to think about that word significant. There probably is a drop, but it is not statistically significant at an alpha of 0.05. And again, remember that this is most likely a very made-up example, so don't put too much stock into it. Always circle your conclusions. And that is a dependent sample or a before and after study, and for those, again, you always want to use a t-test.